Okay, it works, good. Good afternoon, everyone. My name is James Turner, which I put in far too small a font, sorry, but it's there. I work for KDAB, which I put in a bigger font, one of the sponsors of the event, and I'm here to talk to you about static tooling and tailored, customized static tooling for different projects. Building on Clang, which many of you probably know is a open source C++ compiler. Yeah, we asked to show this slide to remind you all that, oh, we're up there, but lots of other people are as well who sponsored the event. So hooray for sponsors. You can say hooray for me, but that's after the talk if it was good. Otherwise, don't worry. Right, so what are we here to talk about? Well, this is not a sales pitch, but at KDAB, what we do is consulting around C++. So we sometimes get called in at the beginning of projects to help with design. That's very nice. We have an empty whiteboard, and we drink a lot of coffee and discuss the problem and design abstractions and classes and hierarchies. But what happens much more commonly is we get called in towards the middle of a project, or maybe towards the end, or some later point in the life cycle. And typically we are reviewing code, repairing code, extending new features, or refactoring it. Often the people who wrote the code have left the company or occasionally been fired for stealing stuff. It depends, you know, just all those scenarios. Or much more likely, like the one guy who knew how the code worked has now finally taken retirement and they can't pay him enough to keep maintaining it, so they're going to pay us instead. And maybe we need to go and learn the code, train up their new developers. Another one is kind of migration, so moving from Qt 3 to Qt 4 to Qt 5, because we also do a lot of work with Qt, migrating to newer versions of C++, whatever. And often it's large customers, so oil and gas, automotive customers, where the project might be really old and really big. So over the years, we have, like, you know, in our internal wiki systems, lots of best practices or common pitfalls we've seen over and over again of dumb things people have done using, in our case, Qt. And, you know, I guess most people have some kind of internal list of things to check for during code reviews, or, you know, standard dumb ways that someone used an API. And of course, if it's something in C++, in the standard library, there may be a compiler warning now. If you run with pedantic, you might get some warnings saying, hey, this is bad practice, this isn't recommended. But of course, that's only for things in the standard library. The minute it's in some third-party code, you don't have that consistent. You just have to, you know, go on Stack Overflow or go on what you learned. And especially as we get to, like, I mean, I've had jobs where I've gone into work and someone's just sent me a zip file of a, you know, entire, you know, code base of 100,000 files and said, right, start fixing this. And that's what we deal with all the time. It's just like, boom, here's the code. Can you start making it better, ideally today? So that's, yeah, that can be quite some work. And we have a saying at KDAB, which is, it's meant as a joke, but everything's a tools problem. We've built tools to ordering lunch at the local Turkish restaurant near the Berlin office. We built tools for tracking time that we spend on things. We built tools for doing our own scheduling. And there are situations where a normal company might just go and buy something in, but we're C++ hackers, so we're like, oh, we can build a tool for this. And also we're lazy. So we don't like doing repetitive work over and over again. So our typical solution to these kind of things is, okay, we're feeling lazy, or we're getting frustrated by this problem, let's see if we can toolize it. One thing you're going to see is we're going to talk about some tooling we've built. What we're very bad at is making products. So most of our tools, in fact, all of them are on GitHub for free, basically because we'd rather do that than try to work out to sell them, because we end up selling, we tried that once, we sold like 4 copies of some tool, and we're like, okay, this isn't worth it. Let's just make the tools be on GitHub, and it's easier for everybody. Because we basically build the tools to make our lives easier, not to try and get rich selling very specialized tooling. So for refactoring C++, finding places where a particular bad pattern is used, we've got some kind of existing weapons in our tool base. So I'm sure you've all used search and replace to go and find all the places where you call one function and change it to call a different function or change the arguments. And depending on your IDE, you may have some even smarter versions of refactoring. Who's done the second one? Who's written some kind of sed or Perl or Python script to transform a C++ code base in some way? Okay, was it fun? Did it break in weird ways on templates or the preprocessor stuff? Right, okay. And so yeah, so that's kind of trying to transform code using a machine, because computers are good at transforming text files. But of course, C++ is like a very, very highly structured text file. This kind of works okay on some level, and the more structured your text file is, the worse sed and Perl transform it. And C++ is very, very structured text. So then the next step that we've done is make like an in-house tool for a particular project. So particular ones that we know about is we do migrations from MFC to Qt, and also from Photon to Qt. Photon is the old QNX user interface library, which is now deprecated. And so QNX recommend using Qt, which obviously is confusing because they both start with a Q, but kind of makes sense. So if you want to do a Photon to Qt migration, we actually built some tooling for that job. So it takes in some of the kind of UI description files that go with these things and the C++ classes, and it can do some semi-automatic transformation. So it can basically give you a skeleton of your dialogues, and you can go and check that it worked correctly, that the right button behaviors became the right actions, and so forth. Has anyone else written a tool like that? Some kind of actual compile tool to modify their code base? Okay. Well, the reason you might not have, and the reason these still fall down, is that, again, handling C++ is hard, right? Handling it correctly is hard, and the time investment is probably not worth it. At least that's the theory. So our solution is called Clazy, because we are good programmers, but also a bit lazy. So it's a tool to transform C++ for some particular reasons, but it's built on libclang and therefore knows about C++. So it's based on Clang, and it's a static analyzer, of which there are many. If you look at static analysis, it's become very popular in the last, let's say, decade, maybe a little bit more recently than that, which does some checks on your code. And particularly, in the case of Clang, it's specialized on code using Qt. There's also Clang Tidy, which has some specializations on, I think, Boost, OpenMP, some other standard libraries. But I want to talk about this more in more general terms of specialized is kind of the word here, because specialized could mean your company or your project. There's also many of my colleagues at KDAB work on KDE, which is one of the big Linux desktops. And KDE is a very large project with some very old code and many different patterns. So there's actually a version of Clazy specialized for KDE called Crazy with a K, because everything in KDE has to start with a K. And so it's really making the point that this is really just like more like a family of ideas of software where you have the one specialized for your needs. But we're going to talk about Clang in particular initially because you can need to have an example. Sorry, with Clazy. So it's free software, it's cross-platform, blah, 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 it's on GitHub, all the usual things. So yeah, it's a way to say, here's a bunch of best practices and run them against a code base. There's some C++ issues in there as well, but they should really just be upstreamed into the main Clang tidy checks. So what does this look like? Well, it looks like a Clang plugin, and the way we wrap that up is with a wrapper script. We've got two modes we can run it in. So I'm now going to do something a little bit dangerous and try and actually run some code inside a presentation. So we've got some source files here which have assorted problems in them, but not problems that are specific to C++, they're specific to the way they use Qt. So this is actually already configured, but what we've effectively done is say export cxx equals Clazy, and then we've run the CMake configuration that picks that up as a compiler variable. So if I do a make now, this is pretty cool. I've got this thing I got from a colleague which lets me run the terminal into the slide, but of course it has a bug, and the bug is there's some weird indentation on the colors, so you'll have to excuse that one. Yeah, you can see here we have essentially just some extra compiler warnings, but they all have Clazy in the name. So this one here, Clazy range loop, And this is because of an interaction as it happens between C++11 range base 4 and the way Qt's smart containers do what's called copy on write. And they're both quite clever systems, but the interaction between the two can cause dumb copying of things like this container returned by get stuff. There's a simple fix, but if you just port some Qt code to C++11 and aren't aware of this, you can actually introduce an awful lot of extra memory copies. So this is a classic example of it's a Qt-specific problem that we're never going to be allowed to put into Clang, because, or even Clang tidy, but it's a very useful thing to check an entire code base for quickly. And the other ones we have, something here, there's, yeah, and again, the actual details of this are kind of specific to using Qt. So this rule about should you use QObjectCast in a child event, that's something very specific, but I'm going to imagine on any large code base you have similar rules for your particular problems, classes, reference counting libraries, whatever, resource ownership rules that you can enforce. Another classic one we have here is that unlike the C++ standard, Qt loves to have multiple versions of everything and multiple overloads. So, for example, this two-lower one is doing an extra copy of the string because there's a version of starts with that can do the two-lower automatically, avoiding one more copy. So the Qt way is to have many kind of ways to solve the same problem, and some of them are less efficient. So this one is just highlighting you could actually do those things with one call rather than two. Yeah, so this is pretty nice. We can, and of course, these obey the normal compiler warning things. We can suppress individual ones in a file and so forth and that kind of thing. There's actually a different mode where we can run it on a compilation database. So this is running as the compiler as well. So when we run it as Clazy, it's also compiling the code. There's this version, Clazy standalone, and what we can do there is if you run cmake with this dexport compile commands. Oh, I need to put a prefix. And we run make again. Yeah, so we now have this compile commands.json, which cmake can produce. And it's kind of meant for IDEs, but it really gives you all the information you need to go and, all the header includes and so forth to run the compiler again. And we can use that to just simply do the Clazy checks on their own without running the compiler. So this is very useful if you're running inside an IDE to basically have a menu item you can add or a shortcut that says, check this code again using Clazy. So we have both ways of operating. That's pretty nice. But it gets better, because maybe if you used a Clang-based compiler, that it has this option to provide these fix-it hints, where it can say, this is what's wrong, or this is what I think is wrong, maybe you should fix it in this way. And as we're going to see when we look at the actual API, we can do those ourselves in our Clang plugin to supply these fix-its. So we actually have the option. It's a little bit brave, but thanks to Git, it's not, you can always go and do a revert. We can tell Clazy to actually apply the fixes automatically. We don't normally let you apply all of them apart from in standalone, and even then I would kind of avoid it. But essentially, if you've looked at a, done some analysis, said, okay, there's lots of this kind of problem happening all over this code base. There's 1,000 places where we get this, queue for each thing wrong. We have a fix-it for that. Actually, we have two different fix-its. So you can even pick fix-it this way or fix-it that way, and you can decide by specifying which fix-it to use in the export. And then we can go and either rewrite your source files or generate a new version of each one with an underscore. So the file's called qvector.cpp, we'll write qvector underscore clazyfix.cpp. But again, if you're running under a Git repository, you can just change the files in place and then do a git diff to see what Clazy changed for you. So this is why we're lazy but good, hopefully, is that we can take a whole code base, go through the fix-its, and gradually do a lot of quality improvements and be sure we've touched all the files, assuming they're in a compilation database, and that we've found those edge cases. Of course, in a new project, we'll probably find some new things that project gets wrong, but that's what brings us to the second part about tailoring the things we warn on even more specifically. So what can we do? Well, we have to split the checks up a bit, especially with those fix-its, because maybe you were thinking, hey, this is going to produce lots of false positives. And the answer is it might. So we split the checks into some levels, and level 0 has no false positives. If something in level 0, we're sure this is just wrong and fine. And then level 1 is like, we're fairly confident it's correct, but you should still maybe check. And level 2 is like, there are going to be false positives in any reasonable size code base. We don't have a level 3, because presumably that would be why you're even trying, but we could have more levels. So we've got different levels of check, and then with each one we've got categories like Qt container classes, around QString, around performance. Of course, some of these overlap. So for each one, we can first of all do the list. You can see I think there's about 40 or 50 right now of the different levels. And each one on its own is quite small. Again, we're going to see when we look at a few checks, that each one is quite self-contained, and we just, as we think of more, we find more, we add them. So yeah, and again, what these actually do, if you know Qt, you might be like, what does that one do? You can come and ask me later, but essentially, you can probably get the idea that each one does some transformation around misuse of a particular class or a particular function. And actually, if I go and do, say, explain on, so here's a here's a level 2 one, which is kind of interesting. Because this one isn't really about Qt. This one is about the rule of 3 for having a custom copy constructor, assignment operator, and destructor, I'm going to say. So this is a level 2 warning, because it might have positives, false positives, but it gives you a warning the class maybe has a copy constructor but doesn't have a assignment operator. And straight away you can see there's some exceptions. So again, because we're assuming you're using Qt with this thing, we know there's some classes in Qt or things or templates you might be building on using Qt, like these Q shared data things, where probably you might be violating these rules and we know it's okay. So we can very pragmatically try and reduce the amount of false positives just by adjusting the code. And again, some other rules, again, to make it hopefully produce less noise and therefore be usable. Because obviously a tool that generates more work for you checking its output than you doing it by hand is not a good tool. So we have to try and be pragmatic. A more kind of specific one, let's go and pick one of the level 1s. So this should be quite easy. QGet. Okay. Yeah, so this is just one where, again, we just have one extra copy. Clazy was originally written by one of my colleagues called Sergio, who does a lot of maintenance work on KDE, and he's a very big proponent of your tools like perf and performance tools will show you kind of your real CPU hotspots, but they're very bad at showing you where you've just lost a bit of time to extra memory allocations and copies across a whole code base. So that's where static tools like Clazy can help to try and find and then fix many small inefficiencies. It's never be worth going through a huge code base and changing all those little uses by hand just to save one memory copy. But if you could do them automatically in a robust way, it could really be worth it. So that's part of the philosophy here. So again, this QGetEnv versus these replacement ones, it's only one memory copy, but okay, and probably you're not calling QGetEnv that often, but then you'd be surprised because people add a debug variable and they check the environment variable inside a hot loop or a hot enough loop, and suddenly they're calling this more than they thought and starts to make a difference. Of course, another fix there is move the QGetEnv out of the hot code, but you get the idea. And of course it has a configuration file, so you can exclude certain directories from your code base. You put this .clazy file in your project and configure which checks you want on, which you want off, files to skip, and so forth. Okay, so that's fine. That's pretty cool for me because I work with Qt every day. Maybe you do, maybe you don't. Obviously, many people do, but this is a C++ conference, not a Qt conference, so maybe it's less interesting for you. But what I want to make the point and show you now is you can do this yourself for your own code bases. So whatever your in-house coding conventions, best practices, known pitfalls are, you can do this. Now, you could do this as a patch to Clazy. You could fork Clazy. You can make your own version. You could also do it as a patch to clang tidy. If you think it's something that could be upstream, that's kind of, there's many places you could do this work in. You could do it as a gigantic Perl script. In theory, that could also work. And of course, once you've got this, either just Clazy itself or a customized version, you should put that on your CI. You should put it as a pre-commit hook on your Git script so that before you even do a commit, it checks you haven't had to increase any more warnings from this tool. That's exactly what we have in lots of working on things like Qt itself. There's various pre-checks that are done so we don't violate any patterns about naming, conventions, file, whatever it is, and check those in a pre-commit, and especially once it hits the CI that we haven't made anything worse. Because we can save an awful lot of frustrating review cycles just if we can catch the dumb errors and the common pitfalls using a machine before it even gets to a code review. These get pretty frustrating. I mean, it's not quite using Clazy, but there's one for the Qt system that checks we've spelt certain words correctly, and I will spell macOS the wrong way because it disagrees how we should spell it. But it just, the more things you can check statically as early as possible, in the end, the more time you save. And the really one that might tempt you here, and I would sort of recommend it, but with care, is if you get told you have to refactor a large code base, this can really be the thing that helps you get it done in a manageable way, beyond just search and replace. Because obviously it'll handle oddities of C++ correctly, because we're going to use essentially a compiler to do the transformation, which builds the full syntax tree for the language. And we often find with large migrations or refactorings that people kind of do the initial stuff, and that's okay. Then they do the kind of the big easy stuff, and they get stuck on like the hard cases. So this is a way to make the machine doable, the regular stuff so easy that hopefully the hard cases are much less work to work on. So yeah, especially as code bases get older and bigger, I think this is a very good way to be able to do changes and also keep the consistency. If you write the check, you can both change the old code and ensure that no one breaks the pattern again, which is pretty handy. So what does this look like? Well, actually, before we go this, who here has written a compiler? Who has written a compiler? Oh, wow, okay. Who's written a compiler for a C-like language? So my university made us write a C compiler during our compiler development course. Anyone try to write a parser for C++? Yeah, I mean, you can do it, but so this is really the big thing that changed, and actually I would almost argue part of the reason for the increase in availability of tooling in the last 5 or 8 years is because Clang exists, because we have a open source, durable, documented API for talking about C++ code and C code in a structured way. So libclang has an API, which we're going to see. If you've never written a compiler, so this thing, an AST is an abstract syntax tree. It's a bit like an XML document for the code that has a root and then leafs and leafs and leafs down to your functions, arguments, brackets, everything. So essentially, if you have an AST, you can traverse it like you would any other kind of hierarchical structure and reason about calls, functions, loops, and so forth. It's exactly what we want to do for Clazy. And of course, then we want to generate some warnings. And the good thing is that Clang gives us all those pieces. So as a Clang, as a Clang plugin, we can use the API, do this work, and that's exactly what Clazy does. We're going to see that there's lots of helpers built into Clazy, so that's why you might want to use Clazy as a starting point rather than just raw libclang, because there's lots of nice convenience that we've added on top, but you can decide if that's worth it or not worth it. That's what we call a basic check. There's actually a second API called the AST matcher. If you've used something like xquery for XML or XPath, this is so again, there's this notion of an AST, and here you define essentially a bit like a regular expression, but to match portions of the AST. So you can say, look for functions with this particular name which are called by this structure, so whatever the string is. So you can match little fragments of AST, and when you get a match, you can capture some arguments. Again, think of it like a regular expression, but for a tree structure, and then you can go and call a callback, and again, generate warnings and fix it. And actually, I think I'm not going to say every, but most of the clang tidy checks use the AST matcher, which makes them a little bit more compact to write, but also a little bit reduces some of the things they can detect. So we use both in Clazy. We have, say, the raw API and the AST matcher API, and we use both depending on which makes more sense for the check we're trying to write. Yeah. So I'm just going to dive into a few of the simple checks now. I'm actually going to switch to Visual Studio Code, which hopefully you'll be able to read and show you how simple a check might be. Because I think people have the idea that this stuff needs to be Q string left. Okay. So each check is like this, and ignoring the kind of headers and include stuff. So obviously you see there's a bunch of clang and LLVM includes here. Might also have to be what some Clazy helpers as well. But ignoring that stuff, we're talking about, a screen full of code to implement a check. Can I put the how do I hide this? There we go, sidebar. Right, okay. So it's all based on visiting the AST, so it's a visitor pattern. So the key thing here, I've got a pointer, do I? Nope, didn't bring my pointer. So this visit statement at line 43 visits every statement in the program. As the compilation is proceeding, we get past the statement. So we have a series of checks we can do. So, okay, so if it's a C++ member call expression, we're going to get that. And if it's not a member call or it's not called qstring : left, well, we're done. This check doesn't apply. Of course, it should make your checks efficient because you have lots of them. You're going to be running them all the time on lots and lots of code. And then we're basically going to check for certain arguments. So here we're checking if we're calling qstring left with an integer literal. So that's what that check at line 52, 53 do. So we get the first argument. We see if it's an integer literal, and if it is, we see if the value is 0 or 1. And both of those are actually a problem, and they can be done a better way. So calling either left 0 or left 1 both have a better solution in the Qt API than doing that value. So it's really simple. It catches a small number of problems, but once you've written a check, it'll find those problems forever. Another one, yeah, missing argument. Bit more elaborate. So again, it's kind of this one's a little bit bigger, and again, it starts with this is visiting a declaration. Pardon me. So this is still working? Yes. This is visiting a class declaration. So again, first check in line 61 is this a C++ record, which means a class in Clang. And then we've got some Clazy level checks. So maybe you know, maybe you don't, that there's a common base class for heap allocated objects in Qt called QObject. And if we're not talking about a QObject subclass, we don't care, because there's some rules about the parenting and arguments of the constructors of QObjects, which is what we want to check in this check. So we're going to go and look at that, and if otherwise, we don't care. So again, you could go and feed all your normal C++ through this, and it won't get confused, because we're checking for all these things along the way. And then there's some rules about inherited constructors, and then we're going to go and find all the different constructors we have, and we're going to see what the parent type should be. So this is, again, where we can build in some knowledge. So the parent argument for most QObjects should be the same type, but if it's a QWidget, the parent should be a QWidget. If it's a QQuickItem, it should be a QQuickItem, and so on. So again, we can just encode some little rules that as humans we know, oh yeah, the parent of a widget should be a widget. Well, let's write it as some code. It's not that hard to express this in C++. You're all C++ developers. There's hopefully no code here. This is not difficult C++ to write, to go and reason about what's going on. But we can actually handle those cases and get a nice result. Yeah, and again, so in the end, we can then say, all right, emit warning, and of course, we get the line number, the file number, and we can say, what went wrong and where, and make our errors as informative as possible. Of course, you can still make them uninformative, but I can't save you from that. If you write uninformative errors, well, go work for a compiler vendor. Yeah? Yeah? Yes, exactly. So Exactly. So the abstract syntax tree has declarations and blocks and statements. And this is going to go. This one here is overriding a virtual method, which is visit declaration to go and visit declarations of structs, classes, and so. Exactly. Yeah. So after the parsing is finished, one of the steps is to go and run the visitors we've requested from the plugin. So another one that uses the we've got the this one's nice. So the range loop. So this is one I was talking earlier, where if we use a C++ range-based for, and we're passing in a Qt container, we can get some duplicate copying, which is bad. So this one has a fix-it. So again, it's got some bunch of includes, and where's the meat of it? Yeah. So when we visit a statement, that's on 65, we see if it's a C++ range-based for statement. Again, this all comes from Clang. We don't have to do any work to go and work out, okay, now we're just looking at only the range-based for statements in our program. And we've got this process thing that basically goes and looks at the type of the argument and check if it's a const reference or not, and check if it's a Qt container type. So there's some rules about how these Qt containers work, and we've written them into some helpers in Clazy. So this line 111, this Clazy is Qt COW iterable class. COW is copy on write. This is going to help us that we've built to reason about the kind of patterns that Qt does. And of course, for your code base, you can write your own things, helpers like that, to avoid duplicating it in lots and lots of checks. And yes, it's easy for us now. We've got those in the Clazy code base to reason about Qt code, but writing those for your own code is going to be hopefully the same kind of work. And then the nice thing here is, again, we've got two different ways we can fix this. We can insert a Q as const macro, or we can insert a reference. Both would work. So we've got this. So if the fix-it's enabled, we can go and add on to our list of fix-its. Yeah, okay, here's how you would change this code into some replacement code to fix the problem. And we possibly omit the warning as well. And the final one to show you is the Q color one, because that uses the AST matcher. I've got this right? Yeah, it does. So again, this is the AST matcher. Oh, I've done it again. Sorry. Okay, this uses the AST matcher API from Clang, which again, it's another API to learn, but it works. And here we can do this nice thing where, rather than visiting all the statements, we register an AST matcher, and here we're doing this kind of templating. So we're looking for a constructor expression which has a declaration, and the name of that is a Q color, so a Q color constructor. And then we're going to go and capture argument 0 as a bound parameter. We're going to see in the callback we can use it. So we can basically go and get out argument 0 with the name myLiteral for every Q color constructor. And then rather than go and deal with visiting the whole tree, this will just get called back to us, this function at the last argument will get called back whenever we find a Q color constructor, and we'll have captured the first argument. I'll try not to rip the microphone off. And so you can see here, where have we got to here? Yeah. So here's our callback, which is one of these matcher callbacks. And when it gets run, we can go and extract the parameter, which we call myLiteral, from the result, and we can go in again, look at it, and emit some warnings. So this handle string literal actually does parallel checking. This is actually checking what kind of string you pass. So you can basically create a Q color using a web code like hash ffccaa, but it's more efficient to use the integers than to go and pass in and do the string parsing. So again, it's, if you're doing lots of Q color construction, using the integer version is much, much cheaper than actually parsing a string and looking at the length of it. So this just checks if it's a web style, color string starting with a hash token and being a particular length, and if it is, we'll emit the warning. Cool. So that's basically what I wanted to do, is show you what we can do with it, and then hopefully give you an idea what you can do with it. And of course, again, Clazy is just on GitHub. You can fork it to go and make your Clazy, give it a funny name, obviously. Since this one's called Clazy and the KD one's called Crazy, the obligation is on you to go and think of some name involving AZs, but I'll let you figure that one out. Yeah, and of course, we also accept patches. If you've got something that you're using in Qt that's bugging you, please feel free to submit it. I've talked about tooling in KDAB, so we have some other tools like this, one for doing perf reports called Hotspot, some other features as well, but this is our recurring thing is because we're basically deal with crufty code bases, we have tools for dealing with big code bases. So gamma ray is essentially like a oscilloscope or multimeter for a program based on Qt, and the other ones are more general for memory management and performance. Yes, links I won't worry about too much, but you can go and look at. But apart from, oh, sorry, did you want to speak about that? I'll go, you can come back to it. Yeah, so we're using this a lot ourselves. Put it on your CI if you're using Qt, of course. And yeah, feel free to use it. And there's a couple of questions I wanted to address head off, because why isn't this in Clang Tidy? Well, the answer is about ABIs, which if you're in the last talk will be very funny. So the Clang guys don't want to freeze an ABI. And this is a Clang plugin, and therefore there's an ABI issue. So they don't want to accept every single library under the sun into Clang Tidy directly, because the Clang Tidy will get enormous and very slow to compile. It already supports OpenMP, Boost, I think 3 or 4 other libraries as well, which are quite big. So that's already getting quite big to link, whereas Clazy just does those 50 checks. So we'd like to be a plugin, but there's an ongoing discussion about how to manage that. So for now, it's standalone. If it could just become an official plugin to Clang Tidy, we'd be quite happy. We're not trying to fork down everything. Clang Tidy is sort of the right solution, plus a bit extra, but it's open source, so who cares? And the other thing is, no, it doesn't depend on Qt. There's no Qt code in Clazy, it just runs on Qt code. So you can happily go and use that in a non-Qt-based project for your own stuff. Cool. So that was my answering your questions before you gave them. If you have other questions, let's hear them, I guess. There's a microphone here, but maybe you can just shout and I'll repeat them. We were just desperate for coffee, so that's also fair as well. Yeah?
Which is the difference between Clang Tidy and Clazy?
So Clang Tidy was done by the Clang project and has checks for a bunch of quite standard things like Boost and I've forgotten a few other libraries, but not even things like libping and zlib. Definitely OpenMP and MPI are in there. Maybe OpenSSL and some really, really common libraries. I think maybe one of the XML libraries as well. But they won't accept things specific to Qt into Clang Tidy. So we're forced to do it outside that code base. So we'd like it to be a plugin, but since plugins don't work, we're doing it as a separate application, which is basically the same idea as Clang Tidy, but specific. And then having done that, then say all of, if I go back to the code base, so the actual checks are in these folders here, but what we have in the rest of the code base is a whole bunch of helpers to go and basically like some syntactical sugar on top of the Clang API to make it easy to work with to look for particular kinds of structure like those cute copy on write functions. So again, if you're doing this in-house, obviously you're probably not going to submit your in-house rules for your large company or project back to Clang Tidy. So knowing that you can do it outside Clang Tidy is kind of valuable, whether it be a plugin that you keep in-house or whether it just be a fork of Clazy or a fork of Clang Tidy. That's also completely possible because it's all open source. The licenses let you do that. Cool. Then, yeah, thank you. Where? Which one? Oh, because a web color code looks like.
Oh, there's an extra. Yeah, sure.
That's what web color codes look like, right? So. I actually didn't know. Presumably that means you could actually write. I have no idea if that's legal CSS or not to do four 4 components per web color, but I guess it must be legal because we're allowing for it here, so who knows. I mean, QColor has, I think, has 16-bit resolution internally, so it would make sense that that syntax is legal to get full precision. So yeah, I guess that's the reason. Cool. Yeah, I'll unplug this.